Okay, did you want to go through any of the homework or preparation assignment?
I mean, I haven't done anything, so I'd kind of like to, I guess.
Yeah, that is fine. Okay, so part one, it says, what does it mean to have matched pairs? So if I understand it right, it's only like one population. They all come from one population, both sets of data. It's a pair of observations that's drawn on the individual. Let me see, the individuals selected for the sample, such as a pre-test and a post-test. I think that's the description I got. Let me look at the textbook.
Post-test scores.
Yeah.
This is called a matched pairs design, or we say we have dependent samples.
Yeah.
Matched design involve one population and a pair of observations. So it's two different observations from the same sample.
Yeah, oh. Okay. It's not opening. Sorry, I'm trying to open up the textbook and it's being very slow. Okay. Yeah, it says, or we said we have dependent samples, matched pairs, or paired data designs typically involve one population, and a pair of observations is drawn on the individual selected for the sample. Yeah, it's, this is like a sample such as like a pre-test and post-test. So it says, number two, what are the differences in the hypothesis test between one sample T, sigma unknown, and matched pairs T, open-ended? So what I understand is they're conducted in the same way. The only exception is the pairs of data must be subtracted before being computed.
Okay.
Okay, so part two. So this is where you kind of get into all like you have to like look up all the data and everything. Okay, let's see if I can bring it up. There was a lot of making histogram this week, and I still do not know how to do that on my Excel. It doesn't have it as an option as one of the graphs, so I'm like, how in the heck do I do this?
Hi, Gina.
You do know how to do it?
No, mine does the same thing. It brings up something like a histogram, but it doesn't do the histograms like the ones on the left.
Yeah, yeah. So I tried to Google it, and it was showing, how you put in frequencies, but I was like, wow, this is a lot of steps. Like, so I tried to do it on that quantitative, descriptive, the other program that they gave us, because it has a histogram that it does automatically, but I don't know, it makes it funky looking. I don't know what's wrong with it. Maybe because there's negative numbers in it, so I don't know. Okay, so if we bring up like the factory assembly times.
Gina, your microphone is off.
Oh, is she here?
Yeah.
Hey.
Except for it says your mic's off. So I don't know.
Yeah, it is. It does say that she's muted.
Pre-assembly change, post-assembly change. So you're the majority of the time you're trying to find the difference between the one first test and the second test, right? Like pre-assembly change and post-assembly.
Yeah, exactly.
Okay.
So like, I'm gonna pull up that factory.
I got it pulled up if you need.
Assembly. So you just make a third column right next to it.
Can you guys hear me?
Yes, we can.
Yeah.
Yay.
Sorry, I'm late.
It's okay.
So what are you guys on?
We're going over, Phil has some sick kids with the flu, so he hasn't got to the homework or anything.
Okay.
So we were just going over the preparation assignment.
Okay.
And we're just starting with question 1 and part 2. So we're trying to pull up factory assembly times, and we were just going to go through a couple of those so that I don't think we need to go through the whole thing, Phil, because it's just like the same thing, like a couple times through.
Okay.
So we'll just go through like the matched paired T procedure, the part 1, the design, the study.
Okay.
So let me get that pulled up.
Yeah, I definitely don't want to hang you guys back, but.
Oh no, you're not. More questions.
No, I don't mind going over this with everybody because I felt like a lot of times I was getting the wrong numbers, so obviously I'm like, okay.
And this had there's just a lot of information.
It's a lot of information, a lot of steps, and I think that's where I was like, it's not a bad idea to go through this a few times and, keep practicing because it's a lot of steps.
Okay, so what problem are you guys on?
Just part 2 in the preparation assignment, number 1A.
Okay.
So we're just looking up or I am looking up the factory assembly. Where is that? Okay, it didn't come up. Why did it not come up? Oh, here it is. Okay, so it's got the pre-assembly change and the post-assembly change. And then all you would need to do is in column C, Phil. Column C, you would just do equals, and then the post minus pre.
Oh, I did it. I did it the other way.
Yeah, usually you take the post or the after and you subtract the pre. That's what they kind of showed in the examples.
Post minus.
And it's a negative 0.9. And then you can just take the little crosshairs and pull that down.
Pull it down
and it calculates. It does all the rest, so you don't have to go through individuals.
Yep.
And then you got to take that, all 3 columns, highlight them, and copy, and then put them in that paired sample t-test. It's in the inference one, the copy quantitative inference procedures document. But it's the number 2 tab. Instead of one sample t-test, it's paired sample t-test.
Hold on. Quantitative inference procedures.
Yeah. Yeah, that's the document, and then we were doing one sample t-test last week, so it's the second tab at the bottom, which is paired sample t-test.
Okay.
I posted a question to ask about that. The order that the you know, if you put your first variable first minus your second, or the second minus the first, because
Uh-huh.
in the reading material, the two different examples that they gave us
Mhm.
on the listening one,
Mhm.
music one, you know, they said to put the stressful music first, and then subtract it from, or the stressful music first, and then you subtract the silent music from that. But then in their answer, their illustration, they actually had it switched, so all of the values, you know, were opposite.
Uh-huh.
Instead of being positive, they were negative, and vice versa. And then in
Mhm.
the airplane example, I don't know if you guys did the extra additional example ones in the reading, but in the airplane example, they actually had it both ways. They
Mhm.
they shared the examples for
Both.
both. Yeah.
I don't
So
think it matter, like it could go either way for any like non-definitive ones, but when it says start, finish, or pre-post, I think you always take the post or the second one, the last one, and subtract
that's what I was,
the pre from that.
yeah, right.
So,
That's what I
but
was
like
wondering.
on things like
You would,
in the homework, in the homework assignment, they give like a scouts flint and steel, a battery and steel and wood for starting fires.
right.
So I mean, and it's like, well, there's really not a post. It's just a compare. It's not. There's not a pre or a post. And so in that one, they give both ways of subtracting. So they give both answers.
So then it's
Um,
a matter of making sure that you, when
mhm,
you have to explain the results, making
mhm,
sure that you understand what you're talking about,
mhm.
so that you interpret the information correctly. Is that what?
I think so. That's like, I don't know. That's one of the hard things I have with this class is interpreting stuff, right? I tell you though, I'm appreciative of our group. I just got started a group in my business class, and we started a text group so that we could, keep up with each other
Right.
and be on the same page. And it's just like the most dysfunctional group I've ever been in. I'm just like, oh my goodness, can I get switched? Like on Sunday, one guy was like sending texts about homework, and so another guy said, can you please not send me texts on Sunday? This is the one day I have not to think about homework. And the other guy got really offended, and they got into this big text battle, and it went on for hours. It was terrible. I was just like, oh my gosh. I just like stayed out of it. I didn't like, send any text, but I was just like, oh my goodness. Can I ask the teacher to get switched?
That's wonderful.
Oh, it was bad. It was bad.
Okay. So are you at the are you still trying to figure out how to pull up the
No, I've got all my numbers in, Phil. Or do you got yours?
Yeah,
Okay.
sorry.
That's okay. So on question A, sorry, I got distracted there. It is, what is the research question? So it basically he's trying to figure out if the main assembly line is different than the wait time before, if I'm right. So yeah.
And since it's not, he doesn't know if it's going to be longer or shorter. He just has, it's just not equal to.
Exactly. So it's a two-tailed test. It says state the null and alternative hypothesis. So they did the HA equals mu D equals 0, or HA, yeah. And then HO is, I think I might have the opposite. HO is the mu D equals 0, and then HA is the mu D not equals 0, right?
Yes.
Okay. And then it says, okay, step number 2, to collect the data. Describe the data collection procedures. So he collected the researcher collected.
So he took 9 workers and he just down how many hours or how long it took him, how many minutes
to do 100 products. Yeah.
Yeah.
And it says, describe the data in a short paragraph. Use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. So the graphs, I just didn't do any of those because I can't figure it out how to do it on my Excel. So do you have an easy way, Gina, of doing a histogram on yours?
No, you just have to transfer all of the data from your inference, quantitative inference procedures. You have to plug it back into the, what was that first graph? The first thing that we used. It was
the quantitative, yeah.
The descriptive. So you have to put it back into the descriptive.
So just the difference section or all 3?
Yeah, that's the difference section.
Okay, because it makes a funny graph, like it puts the axis, vertical axis line in the middle of the graph, and so I can't figure out why it's doing that.
So, let me see. Let's pull up the one for this one.
Okay, I'm gonna pull it up too. I've got the inference one open, but let me get the quantitative one, the descriptive one.
Oh, I didn't do my difference. Hold on. So on this one, which one did you do? Did you do variable 1 minus variable 2?
On this one, I did the 2 minus the 1 because the 2 is the post.
That's what I meant. Okay. Oops. And Phil, you know that when you're transferring just your difference column, you have to take out the formula so that you're just transferring the numbers. Does that make sense?
Oh, yeah.
Otherwise, when you put it into the other file, it'll just say reference number.
Maybe that's what mine is wrong. Hold on. No, it doesn't do reference number, but I'm not sure why it makes a funny graph. Yeah, it moves the whole vertical axis line to like the middle of the graph. I think it's because it's the negative, like the zeros on one side. I'm not sure how to fix that.
Well, that might not be a bad thing. 0. Hold on.
Yeah.
I can't get I'm slow today.
That's okay. So we probably need to sort it, right? I mean, that might help a little bit,
Yeah.
but
Yes, you do want to sort it.
yeah, it doesn't move it. It just still makes it look funny. It probably has something to do with the frequencies or something. Let me think.
Okay, so yeah, you should have that line in the middle though. All of them are. So are you talking about where it lists like 0, 1, 2, 3, 4, 5 kind of?
Yes.
And
it's like right in the middle of the
0.
like center bar. Yeah.
Yeah. No. Yeah, that's supposed to be like that.
It is?
Yes.
Yeah, it's because we're dealing with negative numbers.
Okay. Oh, okay. I was like, should it be like that? Because the ones that they put in the books do not look like that at all. Okay.
Okay, so now back to the question then.
Yes. Yeah. It said to describe the data. So like the D with the bar over it is what, negative 1.056?
The D with the bar over it?
Yeah, whatever. That's
the sample difference?
Yeah.
So we would have...
It's the mean. Yeah, the mean sample. Negative 1.056.
I have something different.
Do you?
So I'm getting... Oops, I'm on the wrong one.
It's the mean sample difference, or the mean, difference between variable 1 and variable 2.
I was in the wrong. Okay. Yes, so it would be negative 1.056. I was in 2 sample tests.
Okay.
A paired sample, so I was pulling up different numbers.
Mm-hmm.
Yeah, that's what I got to.
And standard deviation 2.596.
Yep.
And then it says the sample number is 9.
Yeah, because you rounded up.
Right. And it says what type of hypothesis test is appropriate. It's a two-tailed test. It's a paired sample test for mean is appropriate hypothesis test to perform. Okay, what are the requirements for this test? A simple random sample of the population is, if less than 30, needs to make a QQ plot in order to test the numbering or data. So
it's the same, yeah. And so far, all of our requirements are always going to be those 2 things.
Right.
It has to be a normal population.
A simple random, sample with or the sample needs to be larger than 30.
Yeah. And since this one is, obviously much smaller.
Yes.
If you just double check it, because I don't know, for me, I think it's harder to tell from just the histogram.
Mm-hmm.
But if you just click on the QQ plot, it snakes around that line pretty.
Where did you find the QQ plot? In which one?
On your quantitative descriptive statistics.
Oh yeah.
Spread, just click on the Q plots instead of the.
Oh yeah.
All of the informational transfer.
Oh yeah.
But you'll see how it snakes around that line pretty evenly.
Yeah.
So that suggests that it's normal.
Yeah, I think it's pretty normal.
Yeah.
Okay, and then it says C, continue with the test regardless of what you found in part C, compute the test statistic. And so I got a negative 1.220 from that inference page.
Yep.
And the degrees of freedom is 8.
Yep.
And the p-value to the alpha level is 0.257.
Yeah, that's what I got.
And it says make a decision. Do you reject the null hypothesis or fail to reject it? And then because it's
lower,
it's bigger because it's not 0.05 so it's larger than 0.05, so you would fail to reject.
Right.
And then to put it in an English statement, it's just saying we have insufficient evidence to say that blah blah blah. I guess.
Wait, what confidence level were we supposed to be doing?
95 on almost all of them. But yeah, this is it's a 0.05 up at the
top
paragraph, yeah,
Oh,
which is a 95, yeah.
so what is it saying? The next question, present your conclusion. Oh, not that one. Rather than testing a hypothesis, now say you wanted to estimate the mean difference between wait times. What would you do? We'd create a 95% confidence interval using the t-distribution. What is that saying? I don't know if I'm just missing something.
It says, rather than testing a hypothesis, now say you want to estimate the mean difference between wait times at the 95% level. The answer is we would create a 95% confidence interval using t-distribution.
So is that just that formula that we would calculate by hand?
Yeah, or I mean, this is the confidence interval, so I think this is like the, yeah.
I guess I don't really understand what the whole confidence interval and stuff is yet. I don't understand what that question is saying.
All right, I think we should get to the quiz.
Yeah.
We could be here all day trying to figure this stuff out.
Yep. Okay.
Group meeting. Okay, this is lesson 12 homework. No, group meeting.
Don't you dare say that.
Sorry. I almost did it. I'm tired today, I guess. All right. Group meeting, lesson 12.
Okay.
Okay, suppose we have a set of paired data and let D equal X after negative X before. The null hypothesis HOUD equals 0. The alternative hypothesis HAUD or mu D doesn't equal 0, and the population standard deviation sigma is not known. Jordan collects a sample of size n equals 9 and computes D equals 2.2 and SD 3.3. What is the value of the test statistic?
So I wonder if we just punch in all the numbers into the inference.
Okay.
Take out all of the variable 1, variable 2 differences, you know?
Okay.
I'm just going to see if this will work. I don't know if this... But then we put in the sample size would be...
Just put this into the inference, like the 9, 2.2, and 3.3, and clear out the stuff from before.
Yeah, that's what I'm thinking. See if it'll work. Hold on.
Yeah.
So,
now, are you guys using the paired sample t-test?
Yes.
Yes. Is that bad? I don't know.
No, I just wanted to make sure I was on the right page.
So we have...
Is the 9 the difference one?
Well, that's the sample size, so that would be under the N.
Yeah.
And then we have the D bar, 2.2 is the under the mean.
Yeah, and what was that number? Let's see.
0.2 positive.
0.2. Okay.
No, 2.
2.2.
Yeah. And then the standard deviate or the S. The column right next to it is 3.3.
Right next to it is standard deviation was 3.3.
Yeah. So it does give us a test statistic. I just don't know How would we double check this by hand? What formula would we use?
It gives us a test statistic of 2.
So that's what I got too, but how can we double check this by just working it out by hand? So it has
yeah, the formula, let's see, what is that?
because it's the formula for the test statistics. Right?
Yeah.
Statistics.
Let me get that. It's
Okay, so
it's the x minus, mu divided by s divided by the number. But I don't know if that's different for this.
oh wait, that's for the t-score. Hold on. Oh yeah, you're right. So the x bar minus u. So the x bar, since we're doing,
It's the
that'd be the same as the d bar, right?
2.2, yeah, 2.2 minus the. Okay, what's the mu on this? I don't know. Standard deviation is 3.3 divided by, we know it's n, which is 9, but we don't know what the population mean or the mu is.
Okay. Example. Okay, so I guess that won't. Well, we have everything but the mu. So how is there a way to figure that out? Minus the mu. They don't give it to. There's no way. Unless the mean would be the null hypothesis, the value of the null hypothesis, which is 0.
Okay.
Let's just see if it works.
Okay.
In all of the other problems that we've ever done, the mu is the same value as what we're comparing everything against, right? Which is the null hypothesis value. And here it says it's 0. Let's see if it'll work. Yeah.
I come up with I don't know that that's right. I come up with a 2, which is I think what we got, right?
Yeah, that's what I came up with. Okay, so okay, that's right then, because I'm confident that the mu is the same value as the null hypothesis value. And so it would be 0 in this. And I also remember reading somewhere that in these problems, the null hypothesis is always going to be 0.
Yeah. So it says when it says what is the value of the test statistic 2 is right? Because that's what we got in that program, and then calculating it out is what I just got now.
Yeah.
So.
You just put 2, not like 2.0 or.
Oh yeah, good question.
It doesn't say It doesn't say to add any
decimals or anything.
So I'm just gonna put 2.
Interesting.
I know it always makes me nervous when they don't specify.
No, I don't like that.
Okay.
The probability of being greater than 2.0 is 0.0403. Use the alternative hypothesis to determine the p-value for this test.
Well, we already figured that out. Oh, so we would just have to change instead of the not equal to, we would do the greater than, right? The type of test.
Yeah.
I'm trying to figure out if the probability of being greater than.
Mm-hmm.
0.
Yeah. Here you go. Okay,
So it'd be 0.04?
Yeah, that's what I got.
Okay, let me, open up something for my son there. Okay.
So I got 0.040 though, right?
Yeah.
Greater than p-value 0.040. And this says 3 decimals, so. Okay, 0.040. Okay, use the data listed below to answer questions 5 through 10. Copy and paste the data into Excel and make a column of differences. Use the null hypothesis of HO 0 and an alternative, blah, 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 blah. Okay, let me open up just a spreadsheet. Let's see.
So I'm just putting all of this in the same quantitative inference, paired sample testing.
Mm-hmm. Do you guys have a shortcut for taking the information from this and entering it in?
Oh, well,
I copied and pasted it. It really does just drop right in.
Does it? Oh, I'm going to do that then. Okay.
That's what I did too.
I'm sitting here doing it by hand, but I don't want to take all this time. Okay, so copy. Did you do it by group?
Yeah.
Yeah.
So group 1 in variable 1, group 2 in variable 2.
Copy. Okay, paste. Okay. Oh yeah, it did just drop it right in. Okay, I'm going to do the group 2. Copy. Paste. Okay, the difference is take that and
So this is, we need to change back our type of test to not equal to
okay.
instead of greater than. And the significance level is 0.10, so we need to change that to 90.
It needs to be 90. Okay.
Yeah.
10, and it's not equal to. Okay.
And we need to change our. Oh, that's weird. It didn't automatically change it. So our sample should be. How many are there?
20? Are there 20?
I've got 20. Yeah, why didn't it change it in this thing? It's weird. It has all the same information that we entered from the previous.
I wonder if we messed it up because we erased all of the reference numbers.
Oh, yeah, we might have.
You know what I mean? So let me open up another one.
Yeah, I'm going to do the same.
I'm just going to start over. Okay, don't save.
Okay, why did it not open up? Hold on. Copy. This procedure.
There we go.
Save.
That looks a lot better.
I'm still struggling to get it open here. Copy of reference procedures. Okay. Okay, special. Okay. That's better. Okay, I've got to change these things again now. 0.90 and not equal to, right?
Yeah.
Okay. Okay, so I get the numbers 20, and then what is it asking for us on the quiz?
Still way slow here.
It's okay.
What is the D bar?
What is the D bar? Okay, that's just the mean. So,
Maybe 31. What is it? -31.025.
Negative 31.025.
I wish they would use the same word all the time.
Yeah.
Like, instead of D bar, just put mean.
Yeah, no kidding. What is the standard deviation? So that would be
41.
Yeah, it's 341.157.
Okay, hold on. So wait, where are you guys at? So I have.
Okay. You got it all in?
Yeah, but I'm not getting the same numbers. So we put not equal to 0.01 or 0.09 for the confidence. Okay, so for D bar.
It's 0.9, not. It's 0.90 for the confidence, not 0.09.
Yeah. Oh, sorry, I just said it wrong. But,
Oh, it's okay.
But I'm not for your D bar.
Mhm.
I have it didn't calculate the difference. Why did it not do that? So is yours automatically pulling up like a difference column?
Yeah, I copied and pasted from the spreadsheet and just put it all into the variable. This program won't do the difference for you.
Sorry, I'm in the wrong. For some reason, when my thing pulls up, it automatically pulls up the sample test instead of the
Oh, okay.
copy instead of the paired sample.
Yeah.
So it's always wrong. Okay, this is right now. So we've got. So, okay, so question 5, your D bar was negative 31.025?
Yes.
Okay. Are we supposed to go all the way? Yeah, 3 decimals. Okay. And then your standard deviation, for the sample, the difference is 341.157?
157, yeah.
Okay. 341. Okay, I'm caught up now.
And then what is this test statistic?
So, negative 407.
Negative 0.407. I don't know. This series of tests on the homework quiz quiz last week for lesson 11.
Yeah.
Must have entered something wrong because I got the whole series wrong and got like a 70%.
No.
Yeah.
Well, the odds of all of us accidentally entering something wrong.
Yeah, I know. That's why I like doing it with you guys. But it's like when you're in an individual quiz, you have no idea
Right.
if you did something wrong, you know. So, okay, what is the p-value? Round to the 3 decimal places. So the p-value, 689. What is the correct decision based on this evidence? Okay, it's the confidence thing is 0.10.
Yeah.
So this is larger, so you'd fail to reject.
Yeah, that's what I got.
Okay. Suppose your alternative hypothesis HAUD is greater than 0. What is the correct decision based on this evidence?
We just have to go up there and change.
Greater than.
Still the same.
Yeah, the p-value is 0.65561. Do we have to change the confidence level at all? No.
No.
Okay, so it's still the same, right? Failed to reject.
Yeah, that's what I got because it's 0.656.
Yeah.
Okay. Now we've got to start all over again.
Another group of data. Okay. All right. I'm gonna enter all this.
My question though was, what makes me a little nervous is, like in all of those examples, if you instead of subtracting the second variable from the first variable, if you switch it around, it changes your t value and your p value and everything. So it makes me a little bit nervous when we're.
Yeah, it does, but I think as a general rule, you always subtract
the second group from the first.
The first group from the second. Yeah, like when you take group 2, anyways, it's group 2 minus group 1.
Yeah.
So. I know, and there's no like multiple choice on some of these, so it's like we could completely bomb this. And if we do, then I think that's something we could argue with the teacher. Be like, I don't think so.
Well, I think you're right, though. If nothing else, we should be able to rely on because they did say that in the reading.
Yeah.
That you subtract.
Okay. Okay, so equals this minus this. What is wrong with this? Format. No.
So it doesn't tell us what our confidence level should be or anything.
Equals this minus this. Enter. I'm getting a value for subtracting. I don't know what's wrong.
Try clear your column first, and then just do the difference. Then type in your formula.
I wonder if it's this group 2. It came in funny. I'm gonna re-enter that in.
Use the data in the symbol to answer questions.
Higher content.
Data comes from the null hypothesis. Zero.
Copy. Okay, let me try this again. Wow, it's not doing it. I don't know what's wrong. Let's see if I pull it up.
You're definitely in the paired sample t-test.
No, I'm doing this on another spreadsheet, and then I just copy the information, but it's the first one. No, they're all doing it. None of it's coming up right. Let me see. 12. No, that's right. It's just that first one. I'm just going to enter the value. Okay, it's 30 minus 69. Okay. All right.
5 more questions.
Copy. This takes so much time to put everything in.
I'm talking to your friend.
Not yet, honey.
Wait.
I know you are. Just a couple more questions and then I'll get you stuff, okay? Promise.
Can I do 2 questions or 3 questions?
Yep, just a couple more.
Can do these.
All right, I think I got my answers up. Are you guys ready?
Yeah.
Yeah.
Okay, so
So what did you guys do for your confidence in your type?
Because that make me
I switched it back to
will make me
confidence
better.
level to 0.95. That's
yeah,
more of a standard.
that's probably a good idea because that's the standard.
Okay, my computer, how do I stop this? I have to hurry because my computer's automatically going to shut off in 4 minutes.
Okay.
I don't know how to stop my test thing, or the, and then I did the type of test is not equal to.
Yeah. So what is it asking? And I'll go ahead and
It says which is greater, N or DF?
And N is greater because there's 22, and the DF is 21, right?
Yeah.
Okay, your alternative hypothesis is whatever, 0, and you use the significance level of 0.1. What is your p-value? So we just have to change this to
99? Yeah.
And then our p-value will be
0.001.
Yeah.
0.001. Sounds good.
What decision do you make?
You reject the null.
Yep.
Okay.
You decide to try another alternative. This time it's greater than, so we just have to say greater than. Same level of significance. Did the p-value increase or decrease? And it
Increased.
increased.
We failed to reject, right?
Yep. As we have seen, the p-value depends on the alternative hypothesis setting. Aside the data in this problem, do you think a general rule can be made? Which alternative hypothesis will get the smallest p-value? Well, if it increased when we had a
Greater than.
then you would think it would decrease if it's less than. Is this one of those not enough information? Depends on the problem.
I think it does, because in the last couple ones, I think it was different.
Oh, okay. That is one I would want to look at, but I don't have them. Okay, so do we have any other questions?
So are we saying not enough information? Depends on the problem for that one?
I think it does.
Trying to remember, like, all of our past things. I didn't write down all of the. Well, let's just check it right here. So p-value is for greater than, it's 0.999.
Uh-huh.
Change this to less than, it's 0.000. Much smaller. If we put it to not equal to, it's 0.001. So less than is definitely smaller.
Yeah.
Setting aside the data in this problem, do you think a general rule will be made?
I don't know. Does it change with the different data that we've entered, or?
Well, I don't know that it would matter if there's different numbers. Let's see if let me quickly go up and let me do a back up here on my thing. Okay, so in the problem that we did beforehand, greater than the p-value is 0.656.
Mm-hmm.
Less than it's 0.344. That's definitely smaller. Not equal to is 0.6. So it's the same. So I would think the less than is going to be less than. The smallest p-value is always going to be the less than.
Well, I just barely reopened it, and the values that they give us, I put not equal to, and it's at 0.46. Less than is at 0.76, and greater than is at 0.23. So it's the opposite.
Okay, wait. So wait, what did you just do?
So I opened up that quantitative inference procedures thing, and when you open that, it gives you values, like variable 1, variable 2, and the difference. And I just went off of those, and the p-value is opposite. When it's greater than, it's the smallest. When it's less than, it's the greatest, and when it's not equal to, it's in the middle.
So it just depends on the. So it depends on the problem.
Yeah, I think it depends on the problem.
Okay, hold on. Let me. So you just.
He just opened it up. Are you there? Did we lose you? I think we lost her.
Crap.
Okay. I'm gonna open it up like you did and just see.
Okay.
Save. Open. Quantitative inference procedures. Okay, so it gives like a number 5, 10, 15, 20, 15, 20. Is that what you're talking about?
No, in mine it's like 1, 4.
Oh, I'm 3. In the wrong one. Yeah, hold on. Okay, yeah. So, not equal to, it's 0.463. It gets greater with less than. Yeah, I think you're right. Yeah, less than, it's 0.76. Okay. So, yeah, I think you're right.
Okay.
Okay, so are we going to submit it, or is there any other ones we want to go back over?
I think that's it.
Okay. All right, let's submit this and see how.
I submitted. Oh, we got an 83.
Okay.
What did we miss?
The probability of being greater than 2 is 0.0403. Use HA to determine the p-value for this test. We got that one wrong. And we got
14 and 15 wrong. We got the last one right.
We did get that right, which we were not sure. We just went through those 14 and 15 so quick, so.
Yeah.
I didn't even have a chance to look over those. Okay, well, we tried. We were just trying to get through it.
I'll take a B.
I'll take it. Yeah, it's fine. My grade is already. I feel like my grade is already a lost cause in this class.
Likewise.
I'm just like, all right, giving up. All right. Okay. Well, we'll see you on Thursday then for the next one. All right. Take care.
Thank you.
Bye-bye.
See you.